I'm Jonathan Tomkin from the University of Illinois. Imagine the perfect energy source. What properties would it have? I'd like you to take a moment and just jot down some of the things that this perfect energy source, what features it would have. You might have mentioned some of the things that I've put on this list here, things like it being plentiful, sustainable, cheap, concentrated, secure, non-polluting, and so on. So there's a whole range of things that a perfect energy source would have. Of course, we don't live in a perfect world, so we don't get to choose all of these things. The problem with fossil fuels is that they lack certain qualities that we want. They're not sustainable and they are polluting. So perhaps by moving to renewable energy sources, we can find new sources of power that are both sustainable, non-polluting, and perhaps have other useful attributes. For example, maybe they'll be secure, something their countries are not reliant on importing their supplies of energy. There's lots of different types of renewable energy. We're going to look at a survey of them in this lecture and just sort of point out what the trends are and how important they currently are and how they might be important in the future in countries' energy plans. So let's begin with a simple question. What's currently the largest single source of renewable electricity? The answer is hydroelectricity, and it's not a cutting-edge technology. About 10% of the US's electricity supply comes from hydroelectricity today. And for example, this has been going on for a long time. The Hoover Dam was built in 1936. There are environmental impacts of using hydroelectricity, however. They change the ecosystems of rivers, and in particular they can impact the life cycles of fish. And so in many places in the United States, decommissioning is now seen as an environmental good to help the local ecosystems recover. They take out the dams. What's more is that most of the major rivers in the world are now quite heavily dammed, and so there isn't very much scope for greatly increasing the amount of hydroelectricity produced. So hydroelectricity cannot build a bridge between our current energy use and a renewable energy future on its own. Another suggestion, of course, is solar photovoltaic cells, or solar PV. Right now, this is a tiny source of energy around the world. So for example, in the US, it's around 0.1% of the electricity supply. Some countries have more, some countries have less. Maybe solar is a potential way to solve the renewable energy problem. Backing up this argument, we can see that although solar currently now is not a very important part of the energy equation, it's a very quickly growing source of power. Solar power is not just growing, it's growing exponentially. In 2011, the amount of installed power produced by solar electricity increased by 73%. And in the last 5 years, the total amount of solar electricity increased by a factor of 10. Although some observers think that this is a bubble and will not continue too far into the future, if this trend is something to be relied upon, we could quickly see solar become a major part of industrialised countries' energy portfolios. Similarly, wind power is also growing very quickly. It's been doubling every 3 years or so for the last decade. And we currently produce 4 times as much electricity from wind power as we do from solar. So wind power is even more important currently when we talk about renewable energy sources. Nevertheless, wind power is still a tiny part of most countries' electrical needs. So for example, in the United States, it's of the order of 1%. Growth in the US has been rapid in the last decade. If you look at this map and pick out your state, you might be able to see how much the use of wind power has increased. If you live in the southeast, you might notice that there hasn't been so much change. We'll look into that, the reason why the southeast hasn't seen the same growth as been seen in other places in the US, in a minute. One of the drivers for all this growth is better technology, especially for solar cells. As solar cell technology improves, they become much more efficient, so they capture more of the sun's rays to turn into electricity. At the same time, the price of a solar cell has been decreasing year on year for decades. If this trend continues, we could see solar cells become cost competitive with fossil fuels within around a decade. Now, It's not clear that that will happen. Some people think that the current slump in prices of solar cells is due to overproduction. We will see. Renewables do have problems though. As mentioned before, they rely on natural processes, the wind blowing, the sun shining, and so they can't be relied upon as the base load for current energy grids. Another issue with electricity generated by these new renewable sources is that they're not very good for transport. Currently, battery technology does not store energy nearly as compactly as fossil fuels do. If we look at this graph, we can see that batteries have very low energy densities. So that is they don't have very much energy either per unit weight or by unit volume. So that means that if we have an electric car, for example, we either have extremely large sets of batteries and so less storage space, or we have very short ranges because the batteries run out of power before you go 100, 200, 300 kilometres. This is a clear case where the high energy density of fossil fuels is an advantage. A further disadvantage of renewable energies is that on current prices, the only reason that we're seeing this large growth is because of government support. Even with recent reductions in costs, solar power is 3 to 4 times as expensive as traditional sources of electrical energy. And so clearly, if we were to try and make a change towards, say, current technology, solar PV, we would be paying much more for the energy that we use. Furthermore, we can't always build the power plants near the people who use them. This is important because we lose energy when we have to transmit it through the grid. Wind power, for example, is not in the southeast of the United States because the wind doesn't blow very heavily there. Instead, the fastest winds in the United States are found in places like the Rocky West. Not very many people live in the Rockies. If we have the challenge that we have to transmit electricity from one part of a continent to another, then we'll lose efficiency because there will be losses through the electricity grid system. The same issues apply to solar. The sunniest places are not always the places that have the highest population centres or the most industry. So again, to use the United States as an example, we might talk about the southwest as being the sunniest place in the United States. You can get lots of energy for solar power there. Not very many people live in the deserts. So again, we might have the issue of that the efficiency loss from trying to transmit electricity across the continent would outweigh any benefits you might get. Some countries, such as Germany, have put a lot of financial support into producing solar PV. But of course, as you can see from this graph, Germany, being closer to the pole than the equator, has little insulation, and so it is a relatively poor place to install solar power. Furthermore, renewables are highly land intensive. If you have a small, dense country, you might not have the space you need to install the wind farms or solar arrays that you need to produce enough electricity to power your country's needs. Similarly, biofuels are very highly land intensive, and they displace land that could be used for crops for growing food. Food versus fuel is a big issue for biofuels, by the way. From 1974 to 2005, real food prices, when adjusted for inflation, dropped by about 3/4. Since then, prices have reinflated, they've doubled or tripled. And some experts think that a large part of that is the switch to biofuels in some of the advanced countries. Another worrying thing about the use of biofuels is that studies suggest that they also produce a lot of carbon dioxide. So then, although they might be in some ways a renewable energy source, they are not non-polluting. Corn production for biofuel in the US is thought to produce more carbon dioxide per unit of energy than burning petroleum. And I mentioned that biofuel was space intensive. It's been estimated that to replace the US's use of fossil fuels in transport, that is to replace gasoline with ethanol, approximately the entire US corn crop would have to be turned into biofuel. And that is an enormous area. And again, of course, that would push up food prices enormously. So current, or so-called first-generation biofuels are, in most places in the world, no solution. They push up prices of food, one estimate from the World Bank suggested by as much as 75%. There's a terrible energy return on energy invested, barely above 1 for corn and soy. They don't reduce the carbon footprint, and they can't replace petroleum. There's not enough land available. Research continues into so-called second-generation biofuels that might be more efficient, for example, miscanthus grasses, but they still await technological breakthroughs before that they can become useful. So we might ask ourselves then, is it even possible to move to a renewable energy future? And I think it probably is. We would have to accept some changes. Firstly, it would take decades to transition a grid. Secondly, most of these new renewable energy sources are highly space intensive. They need lots of land. So some countries like the United States would be better placed than other countries such as in Europe, like Britain or Germany. Also, it seems quite clear that prices would be much higher. So if we had a renewable energy portfolio, we would be paying more money to heat our homes, light our buildings and so on. Furthermore, we don't have a good solution for transport as yet. Batteries are not a good solution. They're not energy dense, and also they have their own sustainability issues with the mining of things like rare earths, which are not a renewable supply. It does appear though that in many countries, if we were to accept the limitations, it would be possible at great expense and perhaps at our own convenience. We might not be able to travel as much, we might have interrupted supplies of electricity to switch to lower carbon technologies that were renewable. This switch might be too painful for most nations. Is there a better way? Well, some experts think there are. Instead of looking for more sources of energy, maybe we just need to look for ways to use less.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.